Okay, we're going to continue now with part 2 of today's workshop. As soon as I found my glasses. And now we're going to cover the MMA 7660 accelerometer. To use, as I mentioned in the beginning, the accelerometer uses the I2C protocol to communicate with the Raspberry Pi. And we need to do a few steps before we can go ahead and make that work. In order for your Raspberry Pi to use I2C and an I2C bus, it needs to be configured to know that it's supposed to do that. So if I could get everybody to go ahead and open up your Raspi config. I'm a little big on my screen here. There we go. Open up your Raspi config. I think I got a whole lot of screenshots here, but I think we can go through them pretty quick. If you all can follow along with me. If I go too fast, please go ahead and stop me. So when you open your Raspi config, first thing you're going to see is the main menu. Go ahead and narrow down to Advanced Options. Hit Enter to continue. After that, you're going to get this screen. Scroll down until you see the line A7, I2C, Enable, Disable, Automatic Loading of I2C kernel module. Select Enter, or hit Enter. You should get this screen asking if you want it to be enabled. Arrow to Yes, and hit Enter. And you should get the confirmation screen with only one choice, OK. Should be highlighted. Go ahead and hit Enter. You're going to get a second confirmation. What's different here? Oh, the interface, and then the kernel module. Confirmation telling you that the kernel module will now be loaded by default. Click OK. This should get you back to the main menu. Go ahead and arrow over to highlight Finish, and hit Enter. And you should be returned back to your command prompt. Has everybody made it through all of those?
You got it.
Okay. Did everybody get the reboot prompt?
Yes.
See, I wasn't prompted to reboot. I had to reboot manually. I don't understand
Maybe
why.
you already had it configured for I2C, because the first workshop, I think this was one of the setups.
Oh, did we turn that
didn't.
on? Oops.
Yeah.
So some of you may have already had that set up. Okay, is anybody still going through that process? Is everybody back booted and connected to their Pis?
It takes a while.
All right, let me know.
So you probably already have. Original set reboot time. Oh, you rewrote your. Yeah.
Well, you can head back to everyone out of facilities, then I'm gonna try to connect to it.
Oh, no.
Okay,
Hey, did we have enough resistors? Yeah, we did. Okay, I was worried that I didn't bring them out. Okay, is anybody still waiting to reboot?
Still waiting.
Still waiting? Okay.
Logging in now.
All right. Okay, we ready to continue? All right. In order to manipulate your accelerometer using Python, there's a really neat collection of tools that's baked into apt-get that you can install. It's called I2C Tools Library. Oh wait, I'm sorry, called Python SM Bus, which is an I2C Tools Library. And SM Bus is actually a subset of I2C, and basically what it is a collection of C language wrappers between your hardware and your Python. Okay. And I also included a link on this page where you can go read volumes of information about the SM bus protocol. I haven't had a chance to go back and digest everything at the kernel.org link, but I'm planning to do so at my next opportunity. So that'll be here on the page anytime you want to come back and have a closer look. So what we need to do now is install the Python SM bus library. Is this something we did in workshop one? Okay, good. That's pretty simple. Just do sudo apt-get install python-sm bus. I would probably recommend against copying and pasting this because it looks like we're getting Mongolian dashes instead of English.
Yeah, it worked this time.
That time it worked?
Yep.
Okay. So yeah, if y'all could go ahead and install that, let me know when we're done.
Some dependencies too.
Yeah, this one might take a minute, if I remember
It's not that
correctly.
big.
Did anybody complete it yet? Yeah?
Processing triggers.
You're still going? Okay, I'll give you a second. Now is where I learned how to do really cool screenshots. Okay, we're gonna keep going. Basically what you've just done is install code into your Linux kernel that makes your Pi recognize I2C devices. We're gonna take a little detour here and into your file system. If you could go ahead and change your directory cd to /dev and then do a file listing on that directory. We probably should have done it before and after, but if you notice at the bottom of this screenshot, there's now a new device called I2C-1, and that is a newly installed I2C bus, and it's bus 1, thus I2C-1. Your Raspberry Pi can recognize up to one IC² bus. There are other devices out there where you can have multiple buses, but for the purposes of Raspberry Pi and this workshop, we will always be limited to a single bus. And I challenge anyone who can come up with 127 different devices that we can all connect to that bus at the same time. Cameron. So I had a little bit of trivia there. In order to get the most from your I2C, there are several tools that you can install that are freely available again through the app repository. The first of these packages is IC-Tools, which we will also need to install. And I've included a screenshot here that shows the installation of the I2C-Tools library. So if y'all could go ahead and get that installed at this time. And we'll pause for a moment until everyone gets that done.
Now, I think that was a dependency of the SM bus. So, I mean, although you install it, it may not be needed.
Because,
We'll see.
yeah, whenever in the install Python SM, it says following action package, install I2C-.
Right. So that's a dependency of the Python SM bus.
Oh, so we've already got this installed.
You should, but it won't hurt.
I'm eating pizza on television. Sorry, all proud Americans at home.
We're all eating.
Yeah, I'm sure they're doing the same.
At least I have my shirt on this time. Okay, does everybody have I2C-Tools installed? All right. Now, this is a cool part. This is the first cool part. You've installed the IC2 tools, version should be 3.1.1. Next, we're going to use one of those tools to go ahead and scan our newly created I2C bus looking for connected devices. So at the command line, go ahead and type this right here. Oh yeah, sorry. Sudo, because you need root access to access, is it your GPIO pins? Yeah. Sudo I2C detect space -y space 1. Now what those arguments indicate is the -y just goes ahead and answers yes anytime that you'll be prompted for something. And again, that 1 at the end signifies the I2C bus that you're trying to access. And in our case, we only have 1, so that number for us will always be 1. And when you run that, you should see what we see here in the following screenshot. Does everybody have what's in the screenshot? Okay. And although it's exciting to see the first time, it becomes less exciting when you see that there's nothing connected to it. And that's what we're going to do next. Oh, and what you just did there with the I2C detect is that tool goes ahead and sends out a request to every possible address that's on that bus, which we talked about before. It's 127 possible addresses, and then it just listens to see if anything responds. And in this case, nothing did because nothing's connected yet. So which brings us to the next part of this workshop. We're actually going to go ahead now and connect our MMA 7660 accelerometers. This one is actually considerably easier than the DHT22 temperature sensor. I've included a small bill of materials here of everything we're going to need. And I was on the fence with this one. I don't think we really even needed a breadboard for this one. So if you don't have a breadboard, you should be just fine. Just go ahead and put your jumpers directly to your accelerometer. But I went ahead and kept the breadboard in there because the way I have mine set up is I use the left side of my breadboard for the DHT and then the right side for the accelerometer. And I was able to utilize a single power and ground bus to do that. So that was cool. I got them both hooked up at the same time. On the back of your MMA 7660 accelerometer, you should have already silk screened what all the contacts are. Again, there are 5, but we're only going to be using 4. We're going to be using the pins labeled BCC, GND, SCL, and SDA. The BCC is simply a connection to your positive 3.3 volt power rail, which is also pin 1 on your Raspberry Pi. And I will refer you back to the top of the document, to this image, to locate where the pins are. And the next one we're going to use is the ground pin, obviously. Go ahead and connect your ground to any of the ground pins on your Raspberry Pi header. And I just want to talk a little bit about the next two that we're going to use, because they're a little different than just power and ground. The next 2 pins we're going to use are SCL and SDA. And I2C devices only use those two connections to communicate on the bus. SCL is simply just a clock pulse that's generated by your Raspberry Pi, and the SDA is the data line for the information that you're trying to communicate. Now, if we go back up here to this diagram, you'll see that there they are right here, SDA and SCL. You can see that the SCL is just a simple square waveform going high and low, and the SDA varies accordingly depending on the information that you're trying to send. So what you see, and I'm not going to use my fingers because you can't see them. Oh, I'm a little bit off the screen here, but that should actually say SDA and SCL. So that's where these two transfer from more abstract to the actual device that you're holding in your hand. Does anyone have any questions on that? Okay. Oh, another thing I wanted to point out too is the pin numbers I've been calling out. This graphic that I'm using was actually kind enough to very prominently and boldly identify our SDA and SCL pins. So below, when I told you pin 3 and pin 5, they are also the designated data and clock pins for I2C devices. And I believe, because the Pi only has one bus, I believe that these are the only two I2C pins on the Pi that are available on the Pi. Looking forward to doing SPI next.
And there's 2 spies.
Yep. That's the black SPI and the white SPI. Who's old enough to remember that? All right.
I have no idea.
That's
Spy versus spy.
SPI versus SPI, Mad Max. I actually, since I'm foreshadowing it, I had so much fun putting this one together. I'm gonna coordinate with Cameron about maybe my next one I could do spies. I don't know if I could fill an entire afternoon with it though. Maybe combine it with maybe SPI in New York.
Spy and 24 NRF L01s, the little radios.
Sorry?
We could do spy and those NRF 24 L01s, the little radios.
Okay.
They talk on the spy board.
Okay. Hit me offline on that.
They're cheap.
But all I know is that after 4 o'clock today, I don't want to look at anything that looks like work for as long as I can. All right, where was we? Dude, there's our I2C, installing IC tools. Yep, looking at our empty. Oh, I forgot to tell you, before you go hooking up wires to your Pi, make sure you power it down. Okay, so everybody understands VCC goes to 3.3 volt power, ground goes to ground, SCL goes to the pin above on the diagram, as well does SDA. And here's a very, very large
Nice graphic.
picture of the 7660 for your viewing pleasure. And there's pins, like I said, the one that we're not going to be using this time is in. Did everyone, did the MMA 7660 that everyone received, did they all have this silk screening on the back? I was kind of hoping that they would, and that we wouldn't have to somehow figure out what the pins were. Okay,
Not
good.
gonna require assembly?
I'm sorry?
Yeah, mine I had to solder the headers into it.
Yeah, I did too. Which almost made me buy a $200 Weller soldering station. It's still coming.
I would recommend doing with a Hakka.
Okay.
Yeah.
They're just as good and a lot cheaper. In fact, in a lot of ways, they're far superior.
I grew up using the blue Weller ones.
What's that called? Hakka?
Hakka.
How do you spell that? High school?
Is it H-A-K-O? Adafruit sells them.
Rise sells them.
H-A-K-K-O.
When somebody finds a link to that, could they please post it in the general channel on Slack? Okay, so everybody's got their Pis powered down, and they got all of their accelerometer contacts connected. Does anyone not have all of their contacts connected? Okay. Okay, then go ahead and power your Pis back up, and we're going to run the I2C tools again. to see our accelerometers now on the network.
That's the 4C.
That's what the 4C is. Well, I'll let everybody get that.
That was something.
Is anybody still booting?
And what's the meaning of the rows and columns of this effect, or these?
Boy, you know, I was straining to remember that for my digital
that's-
logic classes. I know that the 0 through F.
So across, the first word is that first row, and then they give you the bit or byte positions.
So in this case, it would actually be, the byte would be 404C.
Well, the word is laid out there, and you just have 16.
Maybe the I2C is kind of organized around the kind of concept of registers.
Yeah.
Maybe this is like, you're reading that particular register. And
Or
this is a
that-
register map, and that's the value in the register sort of.
I actually counted though on it. I'm pretty sure that if you count up the rows and columns, it comes up to 127. So that leaves us
Unique
one
addresses.
space for every possible unique address.
Except those first.
Oh, here it is. The 4 is from the 40 in the row header, and the C is the
Oh,
column
yeah.
header.
So it's,
Put those together and it's 4C.
Ah,
So if you're 1 to the left, that would be 4B.
so it's redundant.
Yeah, in a way. Excuse me. Okay, does everybody see their device appearing on their bus? I see one person shaking his head. Okay. Do you, can you see at all anything?
Hold me a second, so, let me bring up the.
Yeah, it's
the pen map.
really going to set up right, just, no,
Are you getting any kind of error?
no, just the detection.
Okay. Well, we're almost to the end, so we can come back, circle back and take a look at yours. Okay, now go to the right directory.
is it? Yeah,
If I can find,
yeah.
Switching commercial
let me get that for you here. Dot, dot. Okay, it's gonna be the Austin IoT Workshop / MMA 7660 directory. And this one's kind of really easy because there's only one file in there. And right now I'd like to give a huge shout out to Alan.
You know, I'm not too crazy about this code anyway, because.
We'll get there, we'll get there.
Oh, right.
But
I'm looking for something else right now.
in the
Don't give me too much credit yet.
In the 11th hour, as I was putting this together, I was scrambling out. I couldn't find any usable Python MMA 7660 sample code to use. So I put a shout out on our Slack, and Alan answered the call and got us this MMA 7660.py code, which I went ahead and added to our repository. And like Alan says, you know, this is our first pass through this, and he's already looking for something better than this, so that's how we're gonna evolve this over time. Every time we do it, it's gonna get better. So yeah, I think now all that you got, all that's left to do is, now I gotta make sure you do sudo here. Python MMA 7660 pi. And if all the planets are lined up correctly, there it is. Now, one thing you gotta realize is this is not a loop. It's only set to run 1,000 times and so if you look back and it's gone, I freaked out the first couple of times.
Is it in G's?
I'm sorry?
Is it an acceleration in G's?
I don't have enough information to actually decipher what these numbers mean. All I know is that when I take the accelerometer and I put it up on an angle, the numbers change. So to me, that's an indication that the code is working right. The one anomaly that we did notice, and this will probably be an extra credit exercise, but if anyone can figure out why all of the numbers change the same.
They don't,
They don't?
not completely, they're all close, but you see that they're not all.
That is interesting.
I know
Nearly.
this is, this axis, I don't know if you can see my hand, but this is the axis to me that it seems to be measuring. Cause when I lay it perfectly flat and I go in a different axis, the numbers don't change. So it almost seems to me like all three of these numbers are reflecting the one axis of rotation. And I've looked at the code and I can't see it. But, did everyone get this far?
Not yet.
Okay. Did anyone get this far? Okay, I can't leave until at least one person gets this far.
So this main power.
Does everyone have their accelerometer? Are you seeing any kind of errors or is anything? I'm sorry? Oh, it's working? Okay, good. Good. That's my proof of concept. It tells me that what we have here is working. Now, actually, what's supposed to happen here is when you, again, I got my hand down here, I don't know if you can see it, but when you rotate the accelerometer around, you're supposed to get the numbers that can somehow be converted back to geometric orientation of the chip in a 3D space. X obviously being the X coordinate, Y and Z. But like I said, based on what we're seeing, it only seems to be capturing that movement in the one axis of rotation. When I lift it up that way. And then when I set it back down flat, it goes back down. So it seems, I mean, it's doing something, it's working, and it looks like it's 33% working. But in order to figure out why it doesn't seem to be capturing the other two axes of rotation, we're all gonna have to try to figure that out after the workshop.
One of my numbers is different, so it looks like it's doing something different within the.
I'm sorry?
I said every once in a while, one of my axes is a different number. As I move it, but then they quickly go back to the same number. I guess that is.
Okay.
I'm not sure.
There's another interesting note about accelerometers that I discovered that I'd like to share is, you know, when I think accelerometer chip, right away I think that it's an electronic device. But as I read up on it a little deeper, I discovered that it's just as much a mechanical device as it is an electronic device. They discovered that in the etching process, if they etch away material under the semiconductor layer, then leave like a pit there, that the piece of semiconducting material that covers that opening, they discovered that under motion, it produced very, very minute changes in voltage that could then be measured electronically. So once they made that discovery, they just went ahead and started playing around with it and got all the math and equations right. And now they have honed that production process using that etching technique to very accurately capture and calculate acceleration, orientation based on that thin piece of semiconducting material that's going over that gap. I just wanted to share that. I thought that was real interesting. So that tells me that if you drop one of these from a 10-story building, you can, more than likely, you're gonna do mechanical damage inside the unit that'll cause it not to work anymore. But, does anyone have any questions? Then I think that's all that I got. Yes, sir.
Get an I/O error? Ever encounter an input output error?
I have not. Did you verify your pinouts?
Yeah, I looked at the pictures.
Hey, do this, there's a sudo,
We can take a look at that in a
add
second.
user.
Any other questions?
You have to be running as root because you can't access.
All right, that's it.
Yeah,
Thank you for coming.